Understanding operating systems Windows versus Unix. Operating systems are the backbone of every computing device, acting as the bridge between the user and the hardware. Whether you're using a personal computer, a smartphone, or a server, the operating system, OS, plays a critical role in ensuring everything runs smoothly. But what exactly is an operating system? And how does it work? In this video, we'll dive into the inner workings of two of the most well-known operating systems, Windows and Unix. Each of these systems has its own history, design philosophy, and user base, but they both serve the same fundamental purpose: managing hardware resources and providing a platform for software applications. We'll explore the history behind Windows and Unix and how these systems evolved, the core features that define an OS, like memory management, process handling, and security, how Windows and Unix communicate with hardware and manage system resources, the differences between these two operating systems, and why one might be chosen over the other for certain tasks, the key insights developers need to know about working with these operating systems, from security to cross-platform compatibility. By the end of this video, you'll not only understand the inner workings of these two iconic systems, but also how they have shaped the technology we use today and why it's essential for developers to understand them. What is an operating system? Definition: an operating system, OS, is the fundamental software that manages hardware resources and provides services for computer programs. It acts as a bridge between users and the computer hardware. Key role: OS is responsible for managing resources like CPU, memory, storage, and input-output devices. It ensures that these resources are used efficiently and securely. 1. History of operating systems. Early days. The first OS was developed in the 1950s for mainframe computers. Early OSes were rudimentary and focused primarily on batch processing. Windows OS origin. In 1985, Microsoft released the first version of Windows as a graphical user interface, GUI, for MS-DOS, which was a command-line interface, CLI system. Windows revolutionized computing by providing an easier-to-use interface for people. Evolution. Over time, Windows expanded to include various versions, e.g., Windows XP, Vista, 7, 10, and now 11. It has become the dominant OS for personal computers, largely due to its user-friendly interface, backward compatibility, and support for a wide variety of software. Unix and Unix-like systems. Origin. Unix was developed in the late 1960s and early 1970s at AT&T's Bell Labs by Ken Thompson, Dennis Ritchie, and others. It was designed to be simple, modular, and multitasking. Evolution. Unix became the foundation for many other operating systems, such as Linux and Mac OS. The core idea was to create a multi-user, multitasking, and highly portable system. Influence on modern systems. Mac OS, Linux, and other systems like Android are all Unix-based. 2. Key features of operating systems. Operating systems, whether Windows or Unix-based, share several key features. Memory management ensures that each program gets enough memory to run, manages swapping between RAM and storage, and ensures that programs don't interfere with each other's memory. Process management handles running processes and multitasking. The OS schedules when processes should run on the CPU, ensuring efficient CPU time distribution. File system management controls how files are stored, named, accessed, and managed on storage devices. Security and access control manages user authentication, file permissions, and other security measures to protect the system from unauthorized access. Device management acts as an intermediary between hardware devices, like printers, disk drives, and software programs, ensuring they can communicate without direct interaction. 3. How operating systems communicate with hardware. The OS is like the translator between the hardware, which consists of physical components like CPU, RAM, and storage, and software, applications, and user interfaces. Here's how it works. Hardware Abstraction Layer, HAL. Both Windows and Unix-based systems use the HAL to communicate with hardware. HAL is a part of the OS that isolates the software from the hardware details, meaning software doesn't need to know exactly how the hardware works. Device drivers. OSes use device drivers, which are specific pieces of software designed to interact with hardware. For instance, A video card will have a driver that allows the OS to communicate with the card to display graphics. Kernel. The kernel is the core of the OS. It is responsible for interacting directly with the hardware. In both Windows and Unix-based systems, the kernel controls CPU scheduling, memory allocation, and peripheral device communication. 4. Windows versus Unix, macOS Linux, System Design Windows. Windows is designed to be a user-friendly, GUI-driven system. It's very hardware-friendly, as it supports a wide range of drivers and hardware configurations. This is one of the reasons why Windows is so widely used for personal computers. Unix. Unix is designed with simplicity and modularity in mind. It has a command line interface at its core, though modern systems like macOS have graphical environments built on top of it. Unix is known for its stability, security, and scalability. Command line versus GUI. Windows historically relied on a graphical user interface, whereas Unix-based systems have strong command line interfaces, although macOS has incorporated a GUI on top of its Unix roots. Security. Unix-based systems are often considered more secure by default due to their user privilege model. In Unix, everything is treated as a file, including devices and processes, making it easier to manage permissions. Windows has made significant strides in security, but historically it has been more vulnerable to malware and viruses, especially in its early versions. Performance. Unix-based systems are known for their efficiency and stability, especially in server environments. This is why Linux and macOS, which is Unix-based, are preferred for running servers, and many developers opt for Linux when working with servers. Windows is optimized for a wide range of hardware, but it tends to be more resource-intensive than Unix-like systems. Windows also has more overhead due to its user-friendly GUI. 5. Why can't .exe files be executed on macOS? File format .exe files are Windows executables, which are designed to run specifically on the Windows operating system. Windows OS has a subsystem that understands and can execute .exe files, but macOS does not. System architecture. macOS uses a different executable format called Mach-O, while Windows uses portable executable PE format for .exe files. The two formats are not compatible due to differences in how each system manages memory, processes, and file structure. Emulation or virtualization. There are ways to run Windows programs on macOS, such as through Wine, an emulator that translates Windows calls into Unix system calls, or running a full Windows VM using Parallels or Boot Camp. However, this is not native support and comes with overhead. Apple Silicon. With the transition to M1 M2 chips, Apple Silicon, the architecture has further diverged from x86 64-based systems, making direct execution of .exe files even more difficult unless via emulation. 6. What should developers know? Developers need to be aware of a few key things when working across different operating systems. Cross-platform compatibility. Many modern development frameworks and tools are designed to be cross-platform, like Node.js, Python, or Java. Developers must ensure that their software runs smoothly across both Windows and Unix-based systems. File system differences. Windows uses NTFS, New Technology File System, while Unix systems use file systems like ext4 or HFS. Developers need to be aware of case sensitivity in file names. Unix is case sensitive, while Windows is not. System calls. Developers may need to interact with OS-specific APIs for certain functionalities. System calls on Windows, like create file, are different from those on Unix-based systems, like open in Linux or Mac OS. This can affect how low-level operations, e.g., file handling, memory management, are done. Scripting. Unix-based systems are particularly strong in shell scripting, e.g., bash, zsh. If you're developing for these systems, knowledge of shell scripting can greatly enhance productivity and automation. Windows has PowerShell, which is quite powerful, but traditionally Windows users haven't relied on scripting as much as Unix users. Portability. While Windows is more common in consumer environments, Unix-based systems, especially Linux, are the preferred choice for servers and cloud computing. As a developer, knowing how to write code that can easily be ported between these systems is key to ensuring your software reaches a wide audience. Wrap up: historical significance, design philosophy, and developer insights. As we've seen, the history and design philosophy behind both Windows and Unix systems have played a massive role in shaping the way we use computers today. The development of these operating systems was influenced by distinct goals, user needs, and technological limitations at the time. Windows was designed with accessibility and ease of use in mind, catering to a broad range of users, from home users to large enterprises. Its focus on providing a graphical user interface, GUI, and supporting a variety of hardware made it the dominant OS in personal computing. Unix, on the other hand, was built around the idea of simplicity, efficiency, and flexibility. Its modularity and multitasking capabilities made it ideal for academic, research, and enterprise environments. Unix was also designed to be portable, allowing it to adapt to new hardware platforms, an essential feature that contributed to its longevity and influence on modern systems like Linux and Mac OS. The importance for developers. For developers, understanding how these operating systems work is crucial. Here's why. Optimizing performance. Each OS has different approaches to resource management, like memory, processes, and hardware communication. By understanding these internal mechanisms, developers can write more efficient, optimized code that runs seamlessly on both Windows and Unix-based systems. Cross-platform compatibility. With the rise of cross-platform applications, it's essential for developers to understand the unique system calls, file structures, and command line tools that each OS uses. This knowledge helps in ensuring that applications run smoothly across environments, whether on Windows, Linux, or Mac OS. Security and permissions. Unix-based systems are often praised for their strong security architecture, while Windows has had to evolve over time to address security concerns. Developers must be mindful of these differences, especially when working with permissions, file systems, and user authentication in cross-platform applications. Choosing the right tool for the job. Whether you're building software for a desktop user, a server environment, or embedded systems, knowing the strengths of each OS will allow you to choose the right platform for your application. Unix-based systems often shine in server-side, cloud, and development environments, while Windows dominates in consumer software and gaming. Conclusion: a future of interoperability. In the ever-evolving world of technology, the distinction between Windows and Unix is becoming less pronounced, thanks to the rise of containers, like Docker, virtual machines, and cross-platform frameworks. That said, understanding the foundational differences and history behind these systems is vital for developers to make informed decisions in their work. By gaining a deep understanding of both Windows and Unix, developers can write more efficient, secure, and compatible software, ensuring that it performs well across different environments. The future is all about interoperability, and with the right knowledge, developers can make the most out of both worlds.